Okay, if you remember last time, we were doing some algorithms, not algorithms, but visualizations. And we had accessed this CSV file called housing prices. Okay, and this was the last, I think the last one was the box plot. Okay, this was the box plot which we had done last time, which was based on a new column which we created. That was your exterior new and the sale price. Okay, going ahead, first of all, let me execute all this commands so that I get the data as well. So I am importing pandas, numpy, seaborn, and the PyPlot from the matplot library. This command of inline helps me display the plots which are created on the command prompt. That is, output is seen here itself. No, it's taking too much of time. Here we go. Okay. So this is my shape of my CSV file. Let us quickly go through all of them. Okay, I'll directly jump to the last one. Yeah. Okay. Now going forward, if suppose I have one question today, based on this is the last question which we'll be doing on this housing price table. Now, if suppose I want to find out the relationship between the house exterior and the sale price. So what we did was we created the exterior. We had shown this box plot. These were the exteriors which were created. And we converted the others because the values, if you look at the counts, okay, so vinyl SD had 515, then HD board and so on. So what we did was we kept this 3, plus we converted everything or merged all the other exteriors into one particular category called others. Okay, and this was created through this loop here. Okay, and this the plotting which we did for that. Okay, so we had this 3 exteriors and the rest of them were merged together into others. Now let us see if I want to check whether the exterior, the house exterior and the sale price, depending on how old the house is. Okay, if it is an old house, we'll categorize the houses into 2 categories. That is old and new, based on the condition or the year in which it was built. Now to consider the old houses, all the houses which are less than 2000 years or built in year 2000 and less than that will be treated as old, and the others will be treated as new. Okay, to do that, we will first create or use a where condition to create a new column altogether. So I'll create a new column by the name new house. Okay, and the category values will be either new or old. Okay, so let us use this housing data frame. In this, I'll be creating a new column, new underscore housing. Okay, and using the where clause or the where function, okay, I'll be checking the year built. If it is greater than 2000, it will be new. And if it is less than 2000 or equal to 2000, I'll be treating that as old. Okay, so in the where function in the round brackets, let us use the data frame housing, and the column which I want to compare is year built. Okay, if this is greater than 2000, then new, else old. Okay, so these are the 2 we are categorizing. We are creating, first of all, we are creating a new column, and the name of the new column is new housing. And depending on the year built, the year which is there in that particular record, I'll be either categorizing it as new or old. Okay, let us run this. If this works fine, we'll go ahead. Okay, there's no error. So we are able to create this. Let us see the total number of housing, the value count for new housing. So new underscore, sorry, n is small, new housing dot value count, value underscore counts. This. So we have around 1096 old houses which were built, I think, before 2000, or might be 2000 as well, the year 2000. And there are around 364 new houses. Now, based on this two values or the new column, let us draw a box plot. Okay, so to draw the box plot, I'll be using the Seaborn SNS. Let me check whether we have imported this year itself. Yes, we have. So I'll use CNS, SNS dot box plot into round bracket. Now on the X axis, I'll be plotting the new houses. So X equal to, let me put in double quotes, new underscore housing. Okay. And new housing. Actually, the name should have been something else. It should have been new house instead of new housing. Okay, let it be. So this is my new variable. Then on the Y axis, I'll be putting the sale price. Okay, and let us check it out. Put the data equal to, say, housing. Press enter. Here we go. We have this plots here. Okay, so this is my two box plots, and these are the dots which is above this whisker is your outliers. This line in between is your median. Okay, now one more thing I'll do here is I'll also, I want a label, so HUEU equal to, say, exterior new. So whether we had new before, I think whether we exterior new. Okay, let me run this whole thing. One. Okay. I did not run this one. Fine. Okay. Now what I'll do is I'll run this one. Okay, exterior new, there's an error. Because I have to check whether this variable, because we are starting it again. I think this runs, fine, this runs. So my column exterior new is E capital, N is capital. Okay, now it should, yes, fine. Now, if you look at based on what I'm doing is I'm categorizing previously where I had not categorized as per the exterior new value. That is the four columns which we had, or four values which we had, this values. Okay, vinyl SD, metal SD, others, and SD board. Now I'm differentiating or categorizing it based on old and new. So this is the new one, okay, which has all the three exteriors, which is especially the new one which we have created, and this is for the old one. Okay, now if you look at this diagram, it tells me something, because here you can see this one, especially here the HD border. Okay, there's hardly anything in the exterior new does not have any value as such, whereas in the old one HD board was used frequently. Okay, to check the values, let us group this by the exterior new, and we calculate the count and the median on the sale price. So to do this, I'll use housing dot group by. Now I'll be grouping it by exterior new. okay, and the new housing, both. So here I go exterior new, and the other variable was new housing, new housing. Okay, on this I want to apply the function. So I'll use the aggregate function here. Now the function will be based on the sale price. I want to count and find the median of sale price as well. So here I'm going to pass a dictionary, because on sale price, I have to perform two different functions. So I have sale price, and the key and the value will be a list here. So the first one is the count function, which I want to perform on this, and the other one is median. Okay, and let us run. Okay, invalid syntax, the colon. Fine. Inside the aggregate function, we have forgotten the curly brackets. The curly bracket indicates that it's a dictionary, so dictionary has to be in the curly brackets. Yeah. Fine. So what is happening? This is my new exterior, so it is grouping it by this. Under this, again, the new housing, the new and the old. Okay, and the count for HD board in new is only 1, whereas in old it is 221, and this is the median, this sale price. Okay, so based on this, if you look at the figures, there's a huge change in the new housing and the old house. The new houses are not using HD board anymore. There's only one, you can say, record which is having HD board exterior. Okay, whereas in the old case, there were 221, you can say, houses having HD board. And there's a shift between the HD board and the vinyl. You can see this, the vinyl, even in vinyl, you have 309 exterior using vinyl SD compared to 206 on the old houses. Okay, so using such data, you can also find, let us say, if I want to find the type of exterior changed from new house to, and compare it with the old house. So I can plot a count plot. So if I want a count plot, I can just write SNS dot count plot. The variables will be X, the new housing, and data equal to housing, and I want it as per the exterior new. So I can equal to exterior. Something wrong with the curly brackets. From where did I get this curly bracket? Yeah. So you can see this, depending on the figure itself, you can predict how the values or how the exteriors have changed for the old house and the new house. Okay, so these are some examples which I had specially for plotting. I have taken for you to understand how we go about finding the different relationship between different variables and so on. Now there's one function called, if you remember, PairPlot we had used. So if I want, I can use SNS dot PairPlot into bracket. The data is say housing. It gives you all the plots on based on the variables which are available. Even last time, if you have more variables, plotting all the variables against each other is difficult. So it's I think lots of plotting will come. Okay, last time I had ignored this one because it was taking time, and we plotted only graphs which were related ones. Okay, now again in today's example, I'll will create a new file altogether, and it is a case study based on the cardio good fitness, in which I'll also show you linear regression. Okay, so before we actually implement the simple linear regression on the model which will be creating on this database. There is a database or a CSV file called cardiogoodfitness.csv, and we will be comparing two variables here. The two variables will be the usage of your treadmill, and you can say the miles or the fitness of a particular, you can say, individual. Okay, there are different variables. First of all, I'll show you that. So before, let this run at the background. We will create a new file altogether. Let me if this is going to take lots of time and lots of processing, I think I should stop this one. Let me stop, leave this. Okay, I'll start Jupyter again. We will see that function, the PairPlot, on some other database, especially the one which I'm using, because it has less columns compared to this previous example which we were taking. So let me create a new notebook with Python. Okay, now to start with, I'll be importing my packages. So import numpy as np, import pandas as pd, import let us import matplotlib. Now in this I want to include the pyplot, so it will be dot pyplot as plt. Okay, and let us write one more, that is inline. So %sign matplotlib inline. Okay, run this. This is done. Now I want to check whether I have a database which is imported. So I want a database called cardio. So let me check it here. If it is not imported, here it is. No, not this one. Cardio. Here it is. So let us open this one. So there are, you can see there are columns like product, age, gender, education, marital status, usage, fitness, income, and miles. Okay, so there's a product which is some treadmill is there. Okay, and we'll be doing some analysis on that. So it is already there in my, you can say, parent directory, working directory. So let me open this file. Let us use my data equal to the panda alias as pd.read csv, read underscore csv into bracket. The name of my file is audio good run this. It's okay. Let us see some data. So I'll just show you some the top head records. Okay, this is how my sample records looks like. So we have the product name, we have the age, gender, education, marital status, usage, fitness, income, and miles. These are my columns. Okay, if you want to see the, you can say, your statistics, you can use the describe function to include all the statistics. So my data dot describe, and if I want to include all of them, so you can give include equal to say all. If you remember last time when we were trying this out, include equal to all, it was giving me string error, which was because of the total row which we had added at the end of the record. That was the reason. Now this is how it looks. Let me give 30. Fine. We will display it in a better way. So these are my, columns, and these are the values. So around 180 records are there. Okay, 3 unique product. That means there are basically 3 products. Okay, then this is the top value, frequency, mean, and so on. Okay, and wherever we have this value NaN, that is because it is not a number, it is not able to calculate the standard deviation mean, and the 25% quantile, 50% quantile, and so on. Okay, now later on there's one more function which gives you the info about the data set. So my data dot info, this will tell me what are different types of data types I have. So product is object, age is integer, object again. These objects are nothing but your strings. Okay, and the total number of columns and the entries which we have 180. Okay, and the index moves from 0 to 179. So if I display all the records, it will start with the index position 0. Now let us create some histogram and try to plot some graphs there. So I'll have, say, my data. Now to put a histogram, we make use of the hist function. Let us create a size, figure size. So FIG size equal to, let us have a bigger size, so 20 comma, last time we had 10 comma 10, and we saw 20 comma 20 as well. We have not imported I think a Seaborn, so let us first import Seaborn. So I'll give import Seaborn S. Okay, and we create this. Right, the size, you can see this is my size, and here we get the histogram. Okay, so based on your data which you have, you'll get all the histograms here. Okay, so this age, education, usage, fitness, then income and miles. Now this is not going to give me much of the detail because we are not plotting based on 2 different things. It is displaying all the histograms for that particular data set. Okay, now let us create a box plot based on gender and age, and check, try to find out what are the outliers and what is the median there. So we can get SNS dot box plot into bracket the X, let us put the gender here, and comma, on the Y axis I'll put the age, and the data is equal to my data. Okay, here's my box plot, and as you can see, there's only one outlier here, and that is for your female category. Okay, so age and your gender, the relationship between these two, you can see the outliers, we have only one, especially of higher age. Okay, there's only one, you can say a female lady who is of a higher age, and it's a part of my database. If you want, you can ignore it or you can keep it depending on what your requirement is. Now to check what are the products used by what type of a gender, let us create a cross tab. We have not seen cross tab yet. It's a part, we can make use of the function cross tab, which is in pandas. So we can use pd dot cross tab. It'll just give you the information in rows and columns. Into round bracket, your data is, let us use my data and product column. So product, and I want to check the other one as, say, let us say gender. So I'll just give a comma, and again my data square bracket gender. Okay, so we have this 3 products, TM195, TM498, and TM798. The number of females using this product is 40, male is also 40. There's a imply here, you can see both the male and the female gender is preferring this product TM195. Then we have the other product TM498. where we have 29 females and 31 males. And there's another one where you can see there's a fluctuation in the numbers here. There's 7 females are preferring this one, whereas male prefer more of TM 798. But if you compare it with this other product TM 195, you'll find that males are preferring this as well. So if you look at the balance of this particular three products, actually your trade mills based is actually based on what? The weight and the speed and so on, the weight of the individual, even that matters. So might be these products are based on that. And you find that different numbers, based on different numbers, you can immediately tell key females prefer the first product, that is TM195. Okay, let us also create a you can say cross tab of product and the marital status. So is there any relationship, but we can just check it out, the information which is available. So I'll just use this whole thing from here. I'll copy it. And the next column, as I said, will be marital status. And this product. Okay. Now here you can see again. So if they are married, the partner, they prefer the first machine, single 32. And there's hardly any change here. So 190 TM 195 you can see is more preferred. And especially in partner also, it is more preferred. Then if I want to plot a count plot on product and gender, where we are going to categorize it as per the gender. So we can use CNS dot the count plot function. We want the product, because this is the whole thing is based on the product and the preference, which you can say the customers prefer which type of product. We are trying to find out that. And later on, when we do the linear regression, we'll try to find out the relationship between some variables. So on the X axis, I'll be plotting the product, and I want the gender on. So categorize it. So gender U equals to gen. Okay, and my database data equal to my data. Okay, this is how your diagram looks like. Fine. So even here, if you look at this last product, you can immediately say that the males are preferring this product more compared to the females. Fine. So this small graphs actually gives you a better idea. So no need of using the gross tab, or if you want, you can also check the gross plot and make use of the count plot to plot the graph and check the difference. Now in Excel, we had pivot tables. So if I want to plot pivot tables also through your Python, I can do that. Now let us say I want to plot this product, gender, and marital status together and check it out, the information and pivot table. Now pivot table will be available under pandas, so I can use pd dot pivot table. Okay, inside this, the first parameter is your database. So my name of my database is data frame is my data. And what are the indexes on which I want to keep it? So indexes, let us keep product and gender. And I'll in the column, I'll put the marital status, married, single, or partnered. So I can give index equal to. So because there are two columns, I need to pass the list, product, and say gender. Okay. Comma. And what about the columns? In the columns, I want to pass only marital status. So, marital status. And what is the function? If I have some variables or functions to be applied, I'll be applying some length function. Let us put the length, because I want to count. So I'll give AGG. In this, it is AGG FUNC. equal to LE. Okay, let us run this one and check whether it works. Fine. Now here you can see my you can say index is the product. Okay, this is my product, and the second index is the gender. Now based on this, these are my columns, and the function is applied on this marital status. Okay, and here we have aged and under age, partnered single, education partnered single, and so on. Okay, and these are the numbers. So like this, if you want, you can create multiple pivot tables also. Suppose let us say you have income and you want to check with the other columns. Let us say product and gender again. So I want income as well in there. Let me put it. So I'll just copy this command from top here, paste it, and now in this case, I'll just add one more income. So let me put income here. So based on income, okay, comma, indexes will remain as product and gender, and column status, marital status, and I'll keep this as, let us remove this length. Let us keep this. So we have columns, marital status. Let us check it out. What happens? So it is not counting, it's giving me the value. Okay, so this is my income. You can see female partner income, this is my average income. And for single, this is my average income, or you can call it as mean. Okay, and it has been indexed on product and gender. Okay, if you want some other figure, you can go ahead and do that as well. Okay, now we was checking that PairPlot. So let us see whether we can put the PairPlot here, because we have very less, you can say, columns. So my data, if I get this faster. Okay, there's something happening. Here we go. Fine, this is what we actually get. So when we have less number of columns, we can easily plot all the graphs. Okay, so it is going to look at this first one. This is age versus age. You can see this is the x-axis. So age versus age is actually coming here. So this is my first one. Then age versus education, age versus usage, age versus, say, this is fitness. Now this looks very interesting. The last one, age versus, I think it is income. Okay, so it looks like there is some correlationship here. Okay, and the last one is age versus miles. So even that matters. You can see if, but this is more scattered, you can see, compared to age and income. So there seems to be a big correlation between age and income here. Okay, now if you look at the education, fine, there's hardly anything to be seen there. Okay, again here you can see this relation, income versus age, there's a relationship, and miles. Okay, again miles versus age, also there's some relationship here, and miles versus income, also there's some relationship. Okay, so based on this information, once we do the PairPlot, referring to all these values, it can help me understand which variables I should focus on and try to find the relationship. Okay, if I want to know the, let us say, the standard deviation of the date, my age, I can make use of